Determination enthalpy change of combustion by experiment. The materials and chemicals needed in this experiment are 1. Ethanol, 2. Sprit burner, 3. Water, 4. Beaker, 5. Electronic balance, 6. Tripod, 7. Thermometer, 8. Funnel, 9. Count dropper. Set balance to 0 and weigh the mass of water. The mass of water is equal to 100 grams. Measure initial temperature of water. Initial temperature of water is 26.8 degrees Celsius. By using funnel, pour ethanol in sprit burner. Set balance to 0 and weigh the mass of both sprit burner and ethanol. Initial mass of sprit burner and ethanol is 214.17 grams. Before starting heating, put sprit burner near a beaker contain water in order to minimize loss of heat by convection or radiation. Like this. Switch on sprit burner. Let look arrangement of this apparatus. As you see, Sprit burner is placed near a beaker contain water in order to minimize loss of heat by convection or radiation. During burning alcohol, heat released by burning alcohol is used to increase the temperature of water. Switch off sprit burner and read immediately maximum temperature of water. By reading careful on thermometer. The maximum temperature of water is 59 degrees Celsius. The change in temperature is 32.2 degrees Celsius. During burning alcohol, the mass of alcohol decreases, hence the mass of both sprit burner and ethanol decrease. The mass of sprit burner and ethanol after burning is 212.97 grams. The difference in mass of sprit burner and ethanol before burning and after burning is equal to mass of ethanol burned. The mass of ethanol burned is equal to 1.2 grams. By converting mass of ethanol burned into mole, the mole of ethanol burned is 0.026 mole. Importance thing in this measurement. The heat released by burning alcohol is absorbed by water. Pay attention, I want to repeat this importance thing in this measurement. The heat released by burning alcohol is absorbed by water. If you know heat absorbed by water, you know indirectly heat released by burning alcohol. Heat absorbed by water in this experiment is calculated by the formula below. Heat, Q, is equal to mass of water multiply with specific heat capacity of water multiply with change in temperature. The specific heat capacity of water is equal to 4.18 joule per Celsius gram. The heat absorbed by water is 13,459.6 joule. When 0.026 mole of ethanol is burned completely, it release energy equal to 13,459.6 joule. Hence when 1 mole of ethanol is burned completely, it release energy equal to 517,677 joule. By converting joule into kilojoule, when 1 mole of ethanol is burned completely, it releases 517.6 kilojoule. Enthalpy change of combustion of ethanol is equal to negative 517.6 kilojoule. The negative sign on energy indicate that the reaction is exothermic. The theoretical value of enthalpy change of combustion of ethanol is negative 1371 kJ per mole. This difference between theoretical value and experiment value is due to errors below. 1. Poor heat transfer by beaker. 2. Loss of heat by convection before reach to the beaker. 3. Water lose heat by convection through open beaker. 4. There may be some incomplete combustion. 5. Some fuel may evaporate during the experiment. Definition of standard enthalpy change of combustion. The standard enthalpy change of combustion of a compound is the enthalpy change, which occurs when 1 mole of the compound is burned completely in oxygen under standard conditions, and with everything in its standard state. Meaning of standard condition and standard state. Standard state is the physical state of a substance under standard conditions. Standard conditions are: standard temperature is 298 Kelvin or 25 degrees Celsius. Standard pressure is 1 atmospheric pressure or 100 kilopascals. Standard concentration of 1 molarity. In the description there are links for determining enthalpy change of neutralization and enthalpy change of solution by experiment. Leave comments or questions below. Thank you for watching.